The great philosopher Mark Cuban once said, "It's not about our money or connections, it's about our willingness to outwork and outlearn everyone." I really like this quote. In fact, nothing I'm about to say for the rest of this presentation will be better than this. My presentation has already peaked. It's only downhill from here. Obviously, having money or connections can be very helpful, but in my own career, the single most important asset I've ever had is my willingness to work and to learn. That said, it wasn't always this way. There was a time when I was a slow learner. The year was 1985. I was just starting at IBM and assigned to work at an IBM booth at a trade show. Apple had recently introduced their original Macintosh, and we introduced the IBM PCAT within weeks of it. To show off our advantages, we configured a PCAT so that it would display color graphics, ooh, and play music, ah, things that personal computers really couldn't do back then. To our delight, our multimedia PC continually attracted crowds to our booth, and being a friendly person, I struck up as many conversations as I could with people. However, there's only one conversation that I actually remember. I walked up to this couple and said, "So, when are you due?" No sooner had the words left my lips when the husband's eyes grew really large. He took half a step back as if to get himself out of his wife's peripheral vision, and then he started shaking his head back and forth. I didn't know what his problem was, so I ignored him. His wife said, "What?" "The baby," I said cheerfully. "When are you due?" "I'm not pregnant," she said. Like I said, there have been many times in my life where I have been a slow learner. The great philosopher, Anonymous, once said, "Some people have minds like concrete, all mixed up and permanently set." That day it was drilled home to me that it's not enough to be a good worker. You have to be a fast learner. This concrete mindset is responsible for many of the holy wars we have today in technology. Whether it's Apple versus Android, Windows versus Mac OS versus Chrome OS versus Linux, open source, platforms versus Microsoft's, there really is no shortage of topics for debate in the tech industry. Mind you, I'm not talking about honest differences of opinion. Those are good. Well, not always, but they can be good. Honest differences of opinion are not the problem. I'm talking about those people who are always convinced that they are right. Some people never really learn anything because they know it all too soon. It is easy to see how someone can get that way, though. When something works well for us, we tend to grow fond of it. We may even start to think, "My eyeglasses work great for me, therefore everyone should wear my prescription." For example, I have this friend who is a UVU graduate who manages a team of programmers at a very large and influential Utah-based business. When I asked him what he thought of functional programming, he scoffed and said, "Functional programming? Why would I bother with functional programming? Didn't object-oriented programming win that war long ago?" By the way, for future reference, we Native Americans don't really like to talk about who won what wars long ago. But he is right. In the 1980s and 1990s, object-oriented programming was definitely winning the battle. But in this age of cloud computing, parallel processing, big data, artificial intelligence, functional programming has seen a renaissance. Why? Because functional programming is better suited for today's computing paradigms. And the object-oriented programming languages know that as well, which is why virtually every new feature added to any object-oriented language today is basically something they ripped off from functional programming. Abraham Maslow famously said, "If the only tool you have is a hammer, you tend to see every problem as a nail." Every programmer I know knows more than one language. However, if they are all object-oriented languages, then basically what they have are several hammers. If you really want to expand your tool set and look at things, see problems in a whole new way, learn functional programming. And there's never been a better time to learn functional programming. Want to learn how to program functionally with JavaScript? No problem. You can take a class on that from lynda.com. Want to learn functional programming in C#? Lucky for you, Channel 9's most popular video of October 2017 can show you how to do just that. And if you want to take that idea you have for a killer iPhone app, You can write it functionally in Swift if you want, thanks to Ray. Following Mark Cuban's advice, object-oriented programming languages aren't just working hard, they are learning, and what they are learning is to be functional. So when I say functional programming is trending, I'm not just talking about the numbers of projects being done in a functional programming language. I'm talking about how object-oriented languages are keeping themselves relevant and from being replaced by functional languages by adding functional features with each new release. So that's my introduction. Because there are some non-programmers in the room, let's pause for a moment and talk about what programming is. Say we are part of the crowd at a UVU men's basketball game. Coach Mark Pope calls timeout. The Green Man group runs out onto the floor and begins drumming, and Willie the Wolverine holds up a sign and encourages us all to yell the words on a sign. You ready? Here it is. Are you in? Me neither. There's nothing like a little binary code to kill a person's enthusiasm. For some reason, even non-English speakers prefer Go UVU to binary code. Strictly speaking, computers operate in terms of on and off. That's it. To help us humans communicate better with computers, we've designated the numeral 1 to represent on and 0 to represent off. This is called abstraction. Abstraction organizes computer instructions in ways that make them easier for humans to understand. That said, ones and zeros aren't exactly easy for humans to understand either. Lower level abstractions are close to the metal, like the ones and zeros of binary code, and are faster and easier for computers to execute, but are harder for humans to understand. Consequently, to make things easier for us, over time, we began adding layers of abstraction to the stack. Of course, the more we abstract away from the hardware, the more we tax the resources of the computer. So what is programming? Programming takes the logic that humans can understand and through layers of abstraction expresses that logic in terms a machine can understand. In the olden days of computing, that meant machine language. For most computers in our day, we abstract using layers and tools such as operating systems, high-level programming languages, frameworks, libraries, APIs, etc. So with that as a context, let's talk about how object-oriented programming got to be so popular today. I was fortunate to stumble across this short, 2-minute video clip explaining how object-oriented programming became popular. Check it out. So that's it. That's exactly how it happened. I know because I was there. People like to romanticize history and talk as if there were some industry-wide evaluation of programming methodologies and object-oriented programming won, but it wasn't like that, not at all. Object-oriented programming is popular today because when we showed up at the bus stop, we looked around and saw what everyone else was doing and did it too. Before long, the industry was so dependent on legacy object-oriented programming code, every problem began to look like a nail. As you know, in the beginning, people used binary coding to program computers. These methods were painstakingly slow and terribly expensive, but at least they were really buggy and took forever to get working. Before long, some people began using assembly language instead of binary code. At the time, this was controversial and people were critical of them for using it, but then again, there's no sense in owning a computer if its software is never ready. Soon the world would move up from assembly language and begin to embrace general-purpose programming languages. These languages abstracted from the hardware even further than assembly language, but they were closer to the logic humans could express, so software actually got finished. The first two general-purpose programming languages that are still in existence are Fortran, born in 1957, and Lisp, born in 1958. The interesting thing about these two languages is that they just happen to abstract in two very different ways. Fortran is an imperative language, and Lisp is a functional language. The object-oriented languages of today, like Java, PHP, and C# are descendants of Fortran's family tree. And the functional languages of today, like F#, Elm, and Elixir, come from Lisp's family. To help us understand the differences between these two abstractions, here's a very simplistic comparison of how functional and object-oriented languages solve the same problem. Let's assume that x equals 1, y equals 2, and z equals 3. Can you find a solution for A? The solution is 3. If that makes sense to you, then congratulations, you officially understand functional programming. Here is the imperative expression of that same statement. As you look at the two expressions, you can see that functional programming is not harder than OOP. It just goes about things a bit differently. Let's try another. Notice the differences in punctuation between these two expressions. Instead of parenthesis, the second problem uses square brackets, and instead of commas, it uses semicolons. That means that the second expression is looking for an answer that is a list of 3 numbers, not a single integer solution like the first problem. So, what is the solution for C? C equals 1, 4, 9. Does that make sense to everyone? Just look at how close the functional expression is to how Excel would solve this problem. Most people don't know it, but formulas and spreadsheets are actually functions. In fact, Microsoft Excel is probably the world's most popular functional language. So if you're good with spreadsheets, you're on your way to being good with FP as well. Perhaps you've noticed that I haven't shown you the imperative equivalent to that square function yet. That's because the solution doesn't exactly fit in this space. Here's the imperative code for that problem. It is expressed in an object-oriented programming language called C#. And here is the functional solution to that same problem, coded in F#. This part of the C# code corresponds to the first line of the F# code. And this part of the C# code corresponds to the second line. Please notice the difference in incidental complexity, curly braces, semicolons, for loops, etc. Incidental complexity is the complexity forced on your code by the language. It's what the language needs to do its job. The logic doesn't need this complexity, the language does, and functional programming has far less incidental complexity than OOP. Michael Feathers wrote, "Object-oriented programming makes code understandable by encapsulating moving parts. Functional programming makes code understandable by eliminating moving parts." I like that. While we're looking at code, let's check out this simple line. Most, if not all, programmers have written this line or something similar at some point in their careers. Even so, all the smart people in the room should be saying, huh? Because logically speaking, this line is absolute nonsense. There is no number in the known universe that equals itself after you've added 1 to it. What is happening is that the variable x is being mutated. That line of code is saying, take whatever the value of x is and mutate it to be the sum of whatever it used to be, plus 1. Object-oriented code mutates variables like this all the time. In fact, object-oriented programming depends on mutant data. That's right, in this example, x is a mutant. And by mutant, I don't mean mystique. I mean deformed corn on the cob. Everyone say ew. Ew. Unlike object-oriented programming, functional programming uses immutability. Immutability looks something like this. Logically, this line makes more sense, doesn't it? In functional programming languages, X never changes, and once declared, Y won't change either. This may seem like a small thing, but if your code is going to be run on a system with multiple processors concurrently executing your code, keeping track of the state of a mutating X is a major problem. What is the current value of X? How can one processor know how many +1 mutations the other processors have performed on it? Immutable data is the best way to simplify state management in concurrent and parallel systems. The problem with functional languages in the 1960s is that immutable data requires slightly more memory, which back then was a big deal. As you may know, you can buy an 8 GB flash drive online for $4.74. That's 8 gigabytes for less than $5. For perspective, check out NASA's IBM 7090 mainframe pictured here. As impressive as this looks, it had just 8K of memory. Think about it. These mainframes had way less memory than many of today's modern doorbells. In the early 1960s, mainframe computers used to have between 8K and 64K of memory. Adjusting for inflation, a 64K mainframe would have cost about $107.5 million today. Given those costs, you can see why people were so concerned about every bit of memory usage. And yes, the pun was intended. Here's another way to look at it. This is core memory. In the 1960s, core memory could not be made by machine, it had to be hand-woven. Prominent computer scientist Robert C. Uncle Bob Martin says that when he was a kid in the 1960s, he used to buy core memory like this on 512-byte racks for $512 from Army surplus. At those prices, that means that the 8 gigabytes of memory we take for granted in our devices today would have cost $64 billion back then. I hope you're getting the picture. Given the cost of memory back then, is it any wonder that the industry went the more affordable route? This is why most of us are object-oriented programmers today. There was never an industry consensus that declared object-oriented technology superior. In fact, this was never even really a matter of computer science at all. It was a matter of economics. So with object-oriented code everywhere, why is functional programming trending now? Let's take a moment and look at 3 Turing Award winners. In 1971, John McCarthy, the inventor of the functional programming language Lisp, won an ACM Turing Award. By the way, Dr. McCarthy also invented cloud computing, which just blows my mind. Even way back in 1971, Dr. McCarthy clearly understood that cloud computing and functional programming were always meant for each other. That's why he invented them. Fast forward to 1977, John Backus, the inventor of Fortran, won an ACM Turing Award. When you get a Turing Award, you get to publish a paper, and Dr. Backus used his Turing Award paper as an opportunity to try to convince the world that, now that hardware was more affordable, functional programming is actually better than the way he pioneered. Dr. Backus titled his paper, "Can Programming Be Liberated from the von Neumann Style? A Functional Style and Its Algebra of Programs." Alan Kay is one of my tech heroes. He was a jazz musician with a PhD from the University of Utah. During his career, Dr. Kay was part of the team that invented the graphical user interface, the mouse, the laptop computer, touchscreen tablets, ebooks, Smalltalk. And Dr. Kay coined the term object-oriented programming. I hope you realize how astonishingly significant his work is. Alan Kay basically laid the foundation of modern computing. In 2003, Dr. Kay used his Turing Award paper to tell the world that there are amazing technology innovations already out there that the world was overlooking. Because the tech industry was ignoring these instead of embracing these innovations, Dr. Kay called his paper, "The Computer Revolution Hasn't Happened Yet." While not part of his Turing paper, Alan Kay is critical of today's so-called object-oriented languages, saying, quote, "None of them are object-oriented systems according to my definition. Objects were a radical idea, then they got retrograded," unquote. He's right. Object-oriented programming was born as a great idea about component encapsulation and message passing. but it was implemented by the popular OOP languages of the day as inheritance hierarchies and is-a relationships for future use, which are horrible ideas. What the world labeled as object-oriented programming wasn't actually object-oriented at all. The first OOP, Smalltalk, had higher-order functions and lambdas, features that today are considered key parts of functional languages. As Dr. K said, objects were a radical idea, then they got retrograded. Let's pause for a minute and consider what we just covered. These guys are not just some dudes with opinions. The actual founding fathers of functional programming, imperative programming, and object-oriented programming are all trying to tell our stiff-necked industry that what we've been doing is not the best way forward and that we need to get more functional. Thankfully, some people out there were listening. For example, in 1986, Joe Armstrong, Mike Williams, and Robert Verding designed a new functional language to control their employer's telephony. They named the language Erlang, which was short for Ericsson's language. Erlang did things no other programming language in its day could touch. Its native symmetric multiprocessing, lightweight operation, speed, and reliability had never been seen before in their industry, or any other for that matter. Throughout the 1990s, Ericsson leveraged Erlang to build out its network and gain a competitive advantage. Then in 1998, Ericsson banned the in-house Erlang and made it open source, and began to move to a non-proprietary object-oriented language. This debacle sent Ericsson's tech employees to competitors such as Nortel and T-Mobile. Using the newly open-sourced Erlang, Ericsson's competitors made their networks impressively performant and reliable. Before long, the functional programming language Erlang controlled 40% of the world's data communication. By the way, Ericsson eventually dropped the OOP and returned to Erlang, and some of their key employees returned, but by then their secret sauce was no longer secret. Erlang was out in the wild for everybody to use. Here is a photo of the guy inside Ericsson who made the decision to dump Erlang for the trendy new OOP. Yeah, I'm kidding. About the same time that Erlang was proving itself in Europe, Intel discovered that certain Pentium chips were defective. Under normal use, these defective processors would produce an incorrect calculation about once every 24 days. I was about your age at the time, and I made up jokes about Intel, including, how many Intel engineers does it take to change a light bulb? 3. 1 to change the light bulb and 1 to test it. In response to the Pentium bug, Andy Grove did 3 things, and I really admire him for all 3. First, in December 1994, Intel announced a massive recall of its Pentium processors. The recall cost Intel $475 million, which was an enormous hit for any company to absorb, including Intel. In fact, people wondered out loud if this would take Intel under. Second, Andy Grove ordered that some of the defective Pentium chips be made into keychains. On the back of the keychain it said, quote, "Bad companies are destroyed by crises. Good companies survive them. Great companies are improved by them," unquote. The third thing Intel did was to learn from this crisis and make itself a great company. Intel created a proprietary functional language for use inside Intel to program their chips. This functional language became a key part of Intel's competitive advantage and has helped Intel stay on top of its industry. So in the 1990s, functional programming languages enjoyed impressive successes in the real world. The interesting thing about most of these successes, though, is how quiet the companies were about them. Why? Obviously, it was because they considered functional programming to be a competitive advantage, and they didn't want to give this secret away to their competition. For example, Paul Graham has a PhD in computer science from Harvard, but he's best known as a co-founder of Y Combinator. Dr. Graham attributes the success of his 1995 startup ViaWeb directly to their decision to build their product in a functional language, while their competitors used object-oriented programming. In retrospect, Dr. Graham wrote this on his blog. But with Lisp, our development cycle was so fast that we could sometimes duplicate a new feature within a day or two of a competitor announcing it in a press release. By the time the journalists covering the press release got around to calling us, we would have the feature too. It must have seemed to our competitors that we had some kind of secret weapon, that we were decoding their Enigma traffic or something. In fact, we did have a secret weapon, but it was simpler than they realized. No one was leaking news of their features to us. We were just able to develop software faster than anyone thought possible. In 2002, Intel betrayed object-oriented programmers. It released the first modern desktop processor to implement simultaneous multithreading. Prior to this moment, the ever-increasing complexity of software could count on the ever-increasing clock speeds of processors to keep them performant. Not anymore. Thanks to this shift in processor design, if the software industry was going to continue to take advantage of processor improvements, it was going to have to change the way it built software. Shift happens, of course, but this shift changes the game. On this topic, Michael Swain of Dr. Dobbs wrote, "Chip makers have essentially said that the job of enforcing Moore's law is now a software problem. They will concentrate on putting more and more cores on a die, and it's up to you to recraft your software to take advantage of the parallel processing capabilities of their chips." I'm sorry to say, though, that despite this obvious shift to multi-core processors in 2002, a frighteningly large portion of the software industry continues to party like it's 1999. While you don't have to go functional to go parallel, it certainly is easier. As the great philosopher Anonymous once said, "It is not what a programming language can do that matters, it's what a programming language can make easy." In the very same year that the Pentium bug was discovered, 1994, Yale professor Paul Hudak got an ARPA grant to study programming languages. To test the efficacy of different languages, researchers gave a programming project to 9 independent teams of programmers to code a solution, each team using a different programming language. By the way, all the languages were object-oriented except for one, a pure functional programming language called Haskell. I'm sure you've guessed by now that Haskell, the functional language, won, but it is what happened after it won that makes the story so cool. The functional programming language outscored the object-oriented programming languages by such a ridiculous margin that the researchers wondered if it was an outlier. It could just be that the Haskell team had an extraordinarily capable group, so, in an effort to make the study more fair for the OOPs, they grabbed a graduate student and gave him 7 days to learn Haskell, then made him code a solution to the problem. Sure enough, the graduate student's Haskell solution wasn't as good as the first Haskell solution, but it did outscore all the object-oriented languages by a surprising margin and came in second place. In 2014, the University of California, Davis published a study that sought to answer this question: what is the effect of programming languages on software quality? Isn't that a great question? Haven't you wondered that as well? Are some programming languages more error-prone, while other languages actually help you write higher quality software? I don't know what your opinion is on the impact of language on software quality, but there was a time in my life when I would have answered this question by saying, the language doesn't really matter. If the programmers are proficient at whatever language is being used, and the project is being managed and tested well, the quality of the software should be good, regardless of the language. However, like everyone else, my position was just based on my experience. I had no data to support it. In an attempt to find a credible answer to this question, an answer an entire industry could trust, these researchers studied an enormous data set, 729 software projects from GitHub, with 80 million lines of code, written by 29,000 different developers, with 1.58 million commits and 566,000 bug fix commits. Moreover, the code they studied was not from some obscure or unsuccessful project that had no bearing on software used in the real world. They analyzed the source code of projects such as Linux, Node WebKit, Mongo, Docker, jQuery, Node.js, Rails, Django, CodeIgniter, Bootstrap, Bitcoin, etc. The study considered 17 programming languages, including C#, Objective-C, Go, Java, CoffeeScript, JavaScript, TypeScript, Ruby, PHP, Python, Scala, Clojure, Erlang, and Haskell. So, what did they learn? First, they found that the quality of software is, quote, overwhelmingly dominated by the process factors such as project size, team size, and commit size, unquote. In other words, software quality is largely affected by how the project is managed. That should make sense to us all. Second, they also concluded, quote, the data indicates functional languages are better than procedural languages. It suggests that strong typing is better than weak typing, that static typing is better than dynamic, and managed memory usage is better than unmanaged, unquote. So on the question, what is the effect of programming languages on software quality? The answer is, the data indicates functional languages are better. Of course, just because some study says so, doesn't necessarily mean it's true, right? After all, they told us for decades that margarine was healthier for us than butter, but that didn't turn out to be true. Sadly, I sacrificed many a batch of popcorn on the altar of bad science. However, if you happen to have a mind like concrete and are tempted to dismiss this study because your experience leads you to believe that FP is somehow inferior to OOP, please know that the open-minded people in the room see your photo in the middle of this slide. An unbiased scientific study analyzing a massive data set of 80 million lines of code written in 17 different languages by 29,000 different programmers ridiculously exceeds the lifetime experience of any programmer, including you, especially when you consider that many of these 729 projects contain code that the world depends on every day. In July of 2016, Charles Scalfini wrote an excellent essay entitled, "Goodbye, Object-Oriented Programming." In it, he wrote, "It has taken me years to realize how OO lied to me. I was too wide-eyed and inexperienced and trusting, and I got burned. Goodbye, Object-Oriented Programming. Hello, Functional Programming. It has been so nice to work with you over these past few years." As you may know, Stack Overflow is one of the world's most influential programming resources. In 2017, a survey of developers found these 10 languages to be the most loved programming languages out there. You may find it interesting to know that 5 of the top 10 loved languages are functional languages, as indicated by these blue check marks. 4 more of the top 10 most loved languages heavily incorporate functional programming in their language design, as indicated by the gray check marks. Just look at that for a second. You guys, the world is changing. Are you? I'd like to pause here a moment to remind everyone that I'm not a professor or academic. I'm a business owner. I haven't researched this stuff because I thought I'd one day get to present it to someone. I researched this topic because at Xample, we believe that we have a transformational product that comes along only once in a generation, so I want to give us our best chance for success. In other words, this isn't a theoretical, academic, or hypothetical argument to me. We're putting our own money on this. And we would not be doing it if we thought it would go to waste. Our research has led us to believe that there are 7 real-world reasons to give functional programming a chance. Better software quality, better concurrency, improved developer velocity, lower software development costs, improved scaling, easier team and project management, and higher programmer happiness. There are 3 functional languages that I would recommend you check out: F#, Elm, and Elixir. Let's talk about F# first. When Jet.com was founded in January 2014, they started building their product in an object-oriented programming language called C#. Then after some interesting tests, which I don't have time to get into, they switched and began using a functional language called F# instead. Because F# programmers were hard to find, they hired C# programmers who claimed that they are open to learn functional programming. On August 8, 2016, Walmart announced it would acquire Jet.com for $3.3 billion. How amazing is it that a profitable company would drop a perfectly good online shopping system and spend $3.3 billion to get something else? They must think this new system is quite a competitive advantage. By the way, Jet.com has plenty of other innovations. It's not just their technology stack. I was glad to learn of Walmart's purchase of Jet.com though, because we are building our products with F# as well, and that felt like a very big validation to our technology stack. We chose F# because, thanks to technologies such as Xamarin, Fable, Giraffe, React Native, and UI, F# is the only functional programming language in the world that can be used to build APIs, web apps, native iOS apps, native Android apps, Windows apps, Mac OS apps, Apple Watch apps, Apple TV apps, Xbox apps, back-end services, etc. If you do front-end development, then I strongly recommend you check out Elm. Elm compiles to HTML, CSS, and JavaScript, the 3 most nonsensical languages in wide use today. In addition to F# and Elm, I recommend checking out Elixir. Elixir is a functional language with a Ruby-like syntax that runs on Erlang's infrastructure, so it has Erlang's performance benefits. Now that we've discussed how OOP became popular and why FP is trending now, let's talk about the role libraries, APIs, and frameworks play in all this. More than ever before, programming language depends on code you and your team did not write. Code such as APIs, libraries, frameworks, SDKs, OSs, IDEs, etc. Consequently, if any new language hopes to make it in the real world, it is going to have to work very well with these existing ecosystems. For example, 1 month after Apple introduced the Swift programming language to the world, it was the 16th most popular language in the world. However, had Apple not designed Swift to work with its existing ecosystem for app building, Swift definitely would not have been embraced by most developers. Similarly, just 6 months after Google's Android team announced that the Kotlin programming language has first-class support for Android development, more than 17% of all projects built with Android Studio 3.0 include Kotlin code. It wouldn't have gained this kind of traction if it didn't work with existing Java libraries, APIs, and frameworks on the Android platform. Every major platform has its own ecosystem of mature, proven code that all developers have to use to make their own code work on that platform. In today's world of libraries, APIs, and frameworks, it is not enough for a language to be better. It has to play well with legacy object-oriented systems. These languages on this list are a list of some of the functional programming languages that have found a way to do just that. Okay, one last story, then I'll conclude and answer your questions. In 2007, Brian Acton and Jan Koum left Yahoo and traveled to South America for a break from work. When they got back, they both applied for jobs at Facebook, and both were rejected. They took their savings and decided to build a mobile app. They found a Russian developer on rentacoder.com named Igor Solomanikov and got to work. 7 years later, in February of 2014, Facebook bought their app for $19.3 billion. At the time, WhatsApp was the most popular messaging app in the world. It had 700 million active users, sending over 30 billion messages every day. Also at that time, WhatsApp was sharing 700 million photos a day and 100 million videos. Perhaps even more remarkable than all that is the fact that WhatsApp was doing all this with just 32 engineers. How did they do it? Realizing that WhatsApp would need to scale like nothing else in its time, the founders decided to use a functional programming language that was open sourced in 1998, called Erlang. Yep, WhatsApp chose Ericsson's old functional language because the language, combined with its ecosystem, was a massively scalable system with built-in support for concurrency, distribution, and fault tolerance, making it highly available, highly performant, and highly scalable. And Erlang continues to scale well for Facebook. Today, WhatsApp is still the most popular messaging app in the world, with over 1 billion active users. And now WhatsApp does international voice calls, processing 100 million phone calls per day. And the last data I could find on how many engineers WhatsApp currently has is 50. And according to Facebook, they began to use Erlang with other things as well. In conclusion, I was fortunate to stumble across this video clip of a TED Talk explaining why functional programming is popular today.
So ladies and gentlemen, at TED we talk a lot about leadership and how to make a movement. So let's watch a movement happen, start to finish, in under 3 minutes and dissect some lessons from it. First, of course you know, a leader needs the guts to stand out and be ridiculed. But what he's doing is so easy to follow. So here's his first follower with a crucial role. He's going to show everyone else how to follow. Now notice that the leader embraces him as an equal. So now it's not about the leader anymore, it's about them, plural. Now there he is calling to his friends. Now if you notice that the first follower is actually an underestimated form of leadership in itself. It takes guts to stand out like that. The first follower is what transforms a lone nut into a leader. And here comes a second follower. Now it's not a lone nut, it's not 2 nuts, 3 is a crowd, and a crowd is news. So a movement must be public. It's important to show not just the leader, but the followers, because you find that new followers emulate the followers, not the leader. Now here come 2 more people, and immediately after, 3 more people. Now we've got momentum. This is the tipping point. Now we've got a movement. So Notice that as more people join in, it's less risky. So those that were sitting on the fence before now have no reason not to. They won't stand out, they won't be ridiculed, but they will be part of the in crowd if they hurry. So over the next minute, you'll see all of those that prefer to stick with the crowd, because eventually they would be ridiculed for not joining in. And that's how you make a movement. But let's recap some lessons from this. So first, if you are the type, like the shirtless dancing guy, that is standing alone, remember the importance of nurturing your first few followers as equals. So it's clearly about the movement, not you. Okay, but we might have missed the real lesson here. The biggest lesson, if you noticed, did you catch it? Is that leadership is over-glorified. That yes, it was the shirtless guy was first, and he'll get all the credit, but it was really the first follower that transformed the lone nut into a leader. So as we're told that we should all be leaders, that would be really ineffective. If you really care about starting a movement, have the courage to follow and show others how to follow. And when you find a lone nut doing something great, have the guts to be the first one to stand up and join in. And what a perfect place to do that, TED. Thanks.
Functional programming isn't just trending today. I'd say it's a movement. And it's a movement I hope you will consider joining if you haven't already. After all, it's not about our money or our connections or what our peers are doing. It's about our willingness to outwork and outlearn everyone. Cheers.